and welcome to this demonstration of the Dessia platform's capability. In today's video, we are going to be looking at the ability to generate 3D models, such as the one we can see on the screen, in its different design variations. So what we will be looking at is how to generate all the potential and variable variation of a battery pack design within a given design environment. Now, before we start looking at the platform and all of our design capabilities, it is important to first look at the use case. The use case we are looking at here is how can I speed up the development of an hybrid vehicle? This vehicle can be an automotive, but also any type of vehicle, trains, submarines, whatever. The key thing to understand here is that somewhere within our vehicle, and it's not always as straightforward as on this one, there will be a battery pack that is itself containing modules, so an assembly of elementary cells, and of course, the cells themselves. If we want to look at a vehicle from a pure system point of view, we can break it down like what we see on the right. So it's a simple modelization of the system, but it helps us understand that if we look at the overall vehicle system, it has its own design objectives, right? It can be energy consumption, autonomy, CO2 emission, the cost, etc., etc. But those overall design objectives are actually the consequence of the design objective of the subsystems of this vehicle. So we have the powertrain system, and within the powertrain system, we will have the battery pack, but we also have the cooling systems that allows this powertrain system to function, and so on and so on. So if we want to look at how we can speed up the development of an hybrid vehicle, we could think that we can build an app, we can use AI, for instance, to generate automatically configurations for this vehicle. Let the AI produce various designs and recommend them to the engineer for the engineer to choose. But if we want to do that, rather than building one program for the entire system, we might want to break it down into different programs, each of them tackling a specific part of the design process. And that's exactly what we're going to be doing today. So we're going to be looking at inside the powertrain system, we're going to be looking at the battery pack itself. Now, the battery pack has, of course, dimension, it has a voltage, a capacity, but all of those KPIs actually inherited from the number of modules in series and in parallel that are within the battery pack. But if we look at the module, it's also a declination of what are we doing with the cells that are within each module. So if we look at this problem, there is a high combinatory of different elements that we can play with to be able to produce hundreds, if not millions, of battery pack designs. So one of the core values of Dessia is going to be to help you build an app that is able to make sense of this design complexity and produce the best designs for your use case. And so what we will look at in this specific use case is a simplification of the overall problem. So as an input, we will have a design volume. So this is, for instance, a 3D volume that has been communicated by the customer. The customer wishes for you to design with it this volume. And we'll be looking at one elementary cell that we need to use to produce our design. We could think of a harder problem where you have actually a database of elementary cells and you're trying to figure out which cell you should use, but that will not be covered inside today's use case. So the demo you're going to see has three big steps. The first step of using this CI is to use what we call our Python factory. It's the area in our solution where you will be using Python to develop your models. Now, some of them will be on shelf already provided by Dessia, but some of them you will have to build by yourself. If you have a specific way of looking at a design, if it's a design that hasn't never been looked at before by Dessia, or if it's a specific set of rules that you are using in your company, you will, or we will have to do for you, the development in Python to build those base models. Now, those models will then be put into components. What we call a component is a specific visual representation in our platform of an action that has a set of entry inputs, for instance, and you will be able to use those components and assemble them into bots. A bot is basically a workflow that replicates the way an engineer is actually performing a design process, right? So maybe as a first step, I need to understand what's the design volume, right? So the bot will need to read a step file to read the 3D volume. And then I need to mesh this volume to be able to understand it and break it down into elementary parts. And then I need to design within this volume and so on and so on. And so this bot is an actual replication of how an engineer would go about uh, performing the process. Now, let's head back to Dessia's platform. So I'm already on the platform. I'm not going to walk you through all the features that we have here on the side, but what you need to understand is that you are here looking at the bot. So we are already looking at the last step of the slide I was showing you just before. We will not dive into it, but associated to this, there is of course code that has been developed on Python. And this code, developed into libraries, developed into packages, has actually been uploaded into the platform. So we have an admin section, and inside this admin section, we are able to load Python package, so open source package that we need to use for our application, but also custom libraries that we've developed for Dessia or for the specific customers we are looking at. Now, once those libraries have been imported into the platform, we are able to go on about and build our new bot. So I could hit this new bot button and get into building my first application. But today's use case is about looking at a bot that has already been developed by Dessia. So remember, we've developed our packages in Python. Now we need to look at components and start building our workflow. So what we want to do is break down the workflow to a maximum of simplicity. So we first built elementary workflow that each have their own purpose. There is, for instance, one workflow that is able to start from a geometric boundary and produce a 3D volume of the space in which we need to design. It could also take in input a step file, and that would be it, right? But we decided here to go with geometric boundaries defined by the user. We also have a battery generator. The battery generator is basically taking a range of modules and assembling those modules into the volume that we were given in the beginning. We have a module generator, so it's the step before the battery generator. It takes in entry a cell, so the cell has a given size and mass, and then it produces modules within a certain geometry limit. So we can either define this limit by a number of cell min-max, or we could also define this limit by geometric boundaries for the module itself. Okay. So once we've defined all these elementary workflow, we are able to assemble them into our battery pack generator, which is the overall workflow that is going to take care of producing the battery design. Now, for the sake of being able to read this workflow, we grouped, as you can see, the elementary workflows that I showed before into those blue box over here. So we can find again the workflow that is actually generating our CAD model, right? So this is generating the design volume inside which we need to design. Then there is the module generator. So the module generator is here to, from the cells, be able to generate the base module that we're going to replicate within the overall volume to produce the battery pack. And then finally, we have the battery generator. The battery generator is really here to leverage the two previous steps. So remember the design volume and the module generator, and then we combine them to generate the actual battery pack variations that we're going to look at. Of course, as an output to our workflow, we need to be able to display CAD, so a 3D model. So Dessia has its own geometric modeler to be able to produce 3D designs, but we also have multiplots, so graphs that are going to help us navigate the entirety of solutions that have been generated. So now that my workflow is ready, I could simply run it, right, with a set of data. So here I'm going to ask the user for the input data for the specific workflow. Now, I've already run this workflow with a set of data. So what I'm going to do, I'm going to head on to tasks and I'm going to show the various jobs that I've run. So here we can see that in 25 minutes, I've actually executed a job here. That is job number 149. And I'm going to access the results of this job. Hop. And here I can see the entirety of solutions that have been generated by my application, right? So what I can see here is the entirety of output values. So we can see there are a lot of solutions that have been found. Here I believe I found 502 solutions in 25 minutes. So it means that in 25 minutes, you've actually produced 502 viable designs for your use case. And as you can see, those designs are very different from one another, not only in the number of cells and the number of modules, but also in terms of mass, in terms of the length in different direction of our pack. And this will, of course, influence highly our ability to integrate it into the vehicle, right? So then what we want to do is actually select an area of the graph we are satisfied with. So maybe I was trying to operate within this range. I can, of course, see the correlation between my graph on the left and my graph on the right. So I can also access within the solutions that I've chosen here, the ones that have the best performance depending on other criteria. What is also very important is that from this, I'm able to access all the solutions that have been generated in the database. So we keep in a database all the solutions that we generated through the exploration, and then you are able to access them each individually and to access their CAD model, their CAD model. This is what I was showing on in the beginning. So this is a viewer that you have on the platform. As you can see, the experience is very smooth. And I'm here able to have a look at the design I produce. I can play with it. I can break it down, etc., etc. I can verify that there are no aberrations in the design, because this can happen in the beginning if you forgot to specify one geometric rule, for instance, for what you're trying to produce. And most importantly, once I've found a design that I'm satisfied with and I want to take it further, maybe to take it through some more detailed design or more detailed simulation approach, I can actually export the design from the platform. And I can have various type of exports. For instance, the step format that I could use to produce a 3D, but I can also use other formats if I want to leverage more geometrical type of exports, etc., etc. So this was, in a nutshell, the walkthrough through the Dessia platform. And as you can see, this is really a powerful tool for you, not only to build a knowledge base, a technical knowledge base that can be reused across the company, but it's also a very powerful tool for you to start using more advanced digital intelligence inside your design and inside your design processes. And we demonstrated with Renault, so Renault, the French OEM, that such approach can actually reduce the design time by 80%. And this is game changing. So if you want to start applying those type of methodologies to your product, don't hesitate to reach out to us and we will make it work.